Okay, from our previous discussion, now we will continue what is the response of the low pass and high pass filters for the pulse input, and this side I am taking low pass filter. Okay. So, low pass filter means we have to take series connection of resistor and capacitor, and output is across the capacitor. So, V naught of t here, V I of t, and pulse input will be like this from 0 to T p. Here V volts we can able to assume this is T. And in case of high pass filter, again series connection of resistor and capacitor, but output is to be taken across the resistor. So, here we can tell V naught of t, here V I of t, and we are talking for pulse input 0 to T p, this is T, this is V. Okay, just now we have seen the response, how the resistor voltage and capacitor voltage will be affected for the constant input, and when there is no source, how the resistor voltage will be given to the how the capacitor voltage will be given to the resistor. All these things we have seen. Now, accordingly we are going to give the mathematical equations for that particular concept. Okay. So, how to write regarding this particular concept, in the sense in the examination we have to say when t is less than Tp, input is fixed like step input. So, response is also like the step response only. Okay. That means response is also like step response only until t is equal to Tp. This is valid for high pass filter also. Okay. So, what is the response we got for the step input in case of the low pass filter? Exponentially increasing signal. That means V naught of t is equal to V into 1 minus e power minus t by RC. Okay. This is valid up to t is equal to Tp only. Okay. That means when t is less than Tp, we can able to tell this is the response, and in this case also the response is similar to the step response up to Tp seconds. Okay. For the high pass filter, what is the response of the step input? Means exponentially decreasing signal, that is V into we can write e power minus t by RC, but this is valid up to Tp seconds only. But after Tp, what is happening? After Tp, the stored energy in the capacitor will be given to the resistor. That means the resistor voltage will be decreasing. Okay. So, after t is equal to Tp, that means when t is greater than Tp, the capacitor voltage or Vc, simply Vc, will be decreased because its energy is given to the resistor. Decreasing in which way, which form? Exponentially only. So, exponentially decreasing means we know that we have to take V times e power minus t by RC, but this is happening, this reduction in the capacitor voltage is happening after t is equal to Tp. That means there is a delay, like this we have to take. You should not take simply e power minus t by RC, you should take t minus Tp, because this reduction in the capacitor voltage is not happening at t is equal to 0. This is happening after Tp seconds. After Tp seconds means there is a delay of Tp, that must be indicated like this. Like from signals and systems concept, you can able to take x of t minus t naught is representing the delayed version. Like that, here also you should represent t minus Tp, that is the delayed by Tp seconds. Okay. In a similar manner, at t is equal to Tp, what is happening? There is a sudden change in the input, so that there is a sudden change in the resistor voltage, that means output of the high pass filter. Okay. So, whatever the voltage we have in the output, that should have a sudden change V naught of Tp minus V, like that we have to take. Do not confuse here. V naught of t is the equation because t is the variable, but V naught of Tp is constant. This is indicating value of the signal, value of V naught of t at t is equal to Tp. Okay. So, this is the just value. From this value immediately minus V we have to take, because V is the sudden change available at t is equal to Tp. So, at t is equal to Tp, output will become like this. Okay. Then from that value onwards, exponentially decreasing nature we have to take t. Here also this is happening after Tp seconds by Rc. So, by seeing these equations you may not get a clear idea about this one, but if you see the diagrams, that means waveforms related to this one, you can able to get complete idea. So, see carefully. Input is, I am representing with the dotted lines, this is V volts. Now, output I am going to draw. Okay. So, during the pulse duration, that means from 0 to Tp, capacitor starts charging, capacitor charging up to V volts. Once it is charged up to V volts and the time is also we are taking after Tp now. So, after Tp there is no input. So, capacitor voltage will be given to the resistor. So, that we can take like this. But sometimes what is happening, capacitor will be charged to this V volts before Tp only. Tp is here, for example, it is 3 seconds, but before t is equal to Tp, that means before 3 seconds only, for example, at t is equal to 2 only, capacitor voltage can reach up to 2 V volts, and after that also it is maintaining V volts. Then now it starts decreasing, like this also it is possible. Sometimes what will happen means, no need to wait for the 2 seconds also, it will be charged immediately up to V volts, then it is maintaining V volts up to Tp, then there is a reduction in the capacitor voltage, like this we can take. So, all these things are possible, and one more is also possible, it can charge up to Tp seconds, it can charge up to V volts, okay, it can charge up to V volts after 10 seconds, or it will take 10 seconds for the charging, but Tp itself is 3 seconds only. For example, 10 is here. So, it will reach V volts at 10 seconds. You see how I am taking, it will reach V volts exactly t is equal 10 seconds, but you are not maintaining the input V volts up to 10 seconds. Okay, you are maintaining the input up to 3 seconds only. So, in this particular case, it can charge up to this value only, up to 3 seconds. After that, because of the discontinuity available in the input, that means input is seized, so that whatever the stored energy is there in the capacitor, that will be discharged. So, like this a triangle shaped signal also possible. Okay. This is what you need to understand in the concept here, okay, mainly. So, why all these things are happening? This is purely based on RC, this is purely based on RC value. So, RC should be compared with Tp, RC should be compared with Tp. Input is maintaining V volts up to Tp seconds only, but in this case, for example, I am explaining this case now. So, in this case, capacitor charged up to V volts immediately, okay, within this particular small amount of time only, capacitor charged up to V volts, then it is maintaining up to V, that means it took 1 second only, on x axis time is there. So, RC is 1 second, but Tp is 3 seconds, that means RC is less than Tp. When RC is less than Tp or less than Tp, then capacitor will be charged immediately, so that it will reach the V volts very quickly. Okay. And if you come to this case, here also capacitor charged up to V volts within 2 seconds, but Tp is 3 seconds, that means RC is less than Tp here also. But in this case, what is happening? RC by the end of Tp, it reached V volts exactly. Okay, that means we can compare with rise time. Rise time is up to 90% of the final value. Here we can tell RC is comparable to Tp, so that we will get this type of graph. RC is related to 63.2% of the final value only. So, for example, 63 is here. Here it took tau seconds, that means RC seconds. After that, some more seconds are required to charge up to Tp. But in the final case, if you observe, RC itself is very large. For example, total value is 10. Total value is to charge up to the final value V, it requires 10. So, you can take it requires for example 9 seconds to charge up to 63.2 seconds. Okay. But you are not maintaining the input up to 9 seconds, you are maintaining up to 3 seconds only, that is why this decrement is there here. Okay. So, in this case you can take RC is greater than Tp. So, based upon the RC value only the different waveforms we will get here. Same thing we have to take in case of the high pass filter also. Okay. So, I am taking the cases directly here because already we are familiar with the comparison of the RC with the Tp. If you understand this pulse input, then only you can be comfortable with the square input also. So, RC less than Tp, RC is equal to Tp, RC greater than Tp. So, the rate at which the output changes is based upon the RC only. So, this is the pulse input, and here also pulse input I am taking. So, RC is very small, that means immediately it will be decreased to 0 and maintaining 0 up to Tp, then it will take the sudden change, then quickly it will rise to 0. Okay. The action of the capacitor will be done very quickly, similarly capacitor also. Okay. So, now it is maintaining up to Tp like this, then it will be like this. Then RC is very large, that means it will not be reduced to 0 immediately. To reduce up to 0, it will take larger time, greater than Tp. So, actually it will go like this. If you wait up to this much of time, then it will become 0, but you are not waiting up to that particular time. At T is equal to Tp only, you are making input is 0. Okay. So, that it will come up to here, then it will take the sudden change V volts, then it will increase like this. Okay. Same operation, but by taking different RC values, the output waveform looks differ. Okay. So, this is about the pulse input, the response of the low pass and high pass for the pulse input, like this we can able to take. Okay. And in future we are going to see the square input response also. Square signal we can able to take, symmetrical square signal or unsymmetrical square signal we can take as a repetition of the pulses only. So, the output is also repetition of these responses only. Okay. If you take RC less than Tp for the high pass circuit, for the square input you will get a repetition of these spikes, repetition of this one, repetition of this one, like this you will get. Okay. Thank you.